Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to discuss and study about the displacement diagrams of cam profiles. So there are various displacement diagrams in cam profiles. If the follower motion is uniform velocity and if the follower motion is uniform acceleration and retardation, and if the follower is having a motion of simple harmonic motion. So the types of motions of a follower are: number one, uniform velocity, and second one is simple harmonic motion. And the third one is uniform acceleration and retardation. Uniform acceleration and retardation. If the follower is having a motion of uniform velocity, and suppose if we consider the follower is a knife edge follower or roller follower or flat faced follower, whatever follower may be, the displacement diagram remains the same for the given data of a cam rotation and the lift of the follower. I am considering the case study of one case study I'm going to take it, that is the cam rotation, and we are going to use we are going to draw the three displacement diagrams, that is uniform velocity, during outstroke and return stroke. And if the follower is having a motion of simple harmonic motion during outstroke and return stroke, and also if the follower is having a uniform acceleration and retardation during outstroke and return stroke of the follower. Now here, considering data here, the same data I use the same data and draw the displacement diagrams when the follower is having the uniform velocity again and having second motion, that is simple SHM motion, third one is acceleration and retardation. Now here, the follower moves outwards through 50 millimeters during 120 degrees of cam rotation. That is 120 degrees of cam rotation, that is outstroke angle. The outstroke, that is theta O, equal to 120 degrees. And follower to dwell for next 60 degrees of cam rotation. The next means during outstroke, after the next to outstroke dwell, that is 60 degrees of cam rotation. Follower to return to its starting position during next of cam rotation, that means next to 60 degree, the return stroke, that is 90 degrees. And remaining rest of follower to dwell for the rest of the cam rotation, that comes as, that is 360 degrees. The rest means total is 360 degrees. For one rotation of the cam, the total angle is 360 degrees. So 360 minus 120 minus 60 minus 90. Okay. Now what is this angle comes? This is 90 degrees. Okay. So remaining del. Then if the sum of the angles, all the angles, that is outstroke angle, return stroke, and dwell next to the outstroke, and dwell next to return stroke, the total sum is 360 degrees. Now here, what is the importance of displacement diagram in the case of drawing the cam profiles? In drawing cam profiles, now the displacement diagrams are so important that unless and until without displacement diagrams, we can't draw the cam profiles. So displacement diagrams gives the path of a follower for a particular angle of rotation of a cam. So the diagram indicates the diagram of what is the diagram? The displacement diagram means it is the cam rotation versus the lift of the follower is known as a displacement diagram. Now, it is known as a displacement diagram. Displacement diagram gives the location of the follower for a particular angle of rotation of a cam. So based on this location, taking from the locations of a follower for a particular angle, will mark these locations on the radial lines or tangential lines of a base circle or prime circle of the cam. Then passing through that location points, in the case of knife edge follower, we draw directly joining those locations, whereas in the case of roller follower, we'll draw on the locations on the tracing points, that is named as the tracing points. On tracing points from the displacement diagram, what we will do, we will draw roller followers. We will draw rollers of the follower. The path or the surface touching the roller followers, drawing the curve. That curve is known as a cam profile in the case of a roller follower case. Now I am considering whatever follower may be, what are the types of displacement diagrams? The displacement diagrams are based on the type of follower motion. If the follower motion during outstroke and return stroke is uniform velocity, that is the case 1 we are going to study here. Uniform velocity during outstroke and return stroke. Uniform velocity during outstroke and return stroke. Now, if it is uniform velocity during outstroke and return stroke, we have to draw the displacement diagram. How to draw? The outstroke angle theta O equal to, that is 120 degrees. Theta dwell next to outstroke angle, that is 60 degrees. And theta return stroke equal to 90 degrees. And return next to dwell is remaining angle, that is 360 minus sum of outstroke and theta O plus theta OD plus theta R. Now take the scale. For displacement diagram, we have to take the scale on x-axis. X-axis on x-axis we follow the independent parameters, that is angle of cam rotation. The angle of cam rotation, that is 20 degrees equal to 1 centimeter we consider. Then theta O becomes how much? 6 centimeters. Theta OD becomes 3 centimeters. Theta R becomes 4.5 centimeters. Theta RD, that is also 4.5 centimeters. On y scale, on y-axis, what is the scale? That is 50 millimeters. That is 1 centimeter equal to 1 centimeter. That is the full scale. Equal scale will take. Now what is the first step? We have to draw a x-axis line with the length of sum of these outstroke, theta OD, theta R and theta RD summation, that is linear lengths. We use the scale converting the angles, angle of rotation into linear scale, that is 6 plus 3, 9 plus 9 plus 9, 18. Draw a 18 centimeters straight line or a horizontal line. Mark on this horizontal straight line, divide into outstroke theta O, that is 6 centimeters. So we have to mark it as angles only here. Okay. Next, OD. The OD is 60 degree and theta R 90 degree and theta RD, that is also 90 degree. How much it is? Theta RD is 4.5 centimeters, theta R is 4.5 centimeters, theta OD is 3 centimeters and theta O equal to 6 centimeters. This is x-axis line. We have to use geometry instruments, linear scale, pencil, eraser and compass, and also set squares if necessary. Now draw next vertical line. This is the y-axis line. Complete this, the displacement diagram, close, okay, horizontally. I'm drawing the principles with manual. I'm showing you, but you have to use instrument to draw the straight edge, straight horizontal lines, straight lines. This is the height of 50 millimeter. This y-axis, Y indicates the displacement of the follower or the stroke of the follower. So we already divided the the bottom horizontal line with equal parts. So extend this with vertical lines. So this is also portion of, what is this portion? This portion is outstroke. This portion is dwell. This portion is return stroke. And this is rest of the dwell. So after this, it is uniform velocity. Divide outstroke and return stroke portions of this diagram into even number of parts. It may be 4 or 6, 8, 10 and 12. So according to convenience, but the optimum number of even number of parts are 6. So if it is 4, less clarity. If it is more, time taking. More clarity comes, but time takes more to draw the cam profile. Now, to get clarity at the same time maintaining accuracy, the optimum number of even number of parts are 6. Divide this theta O portion, that is, if you mark it as AS in some of the books, but you can note notations, but you follow as 0. Divide this into equal number of parts, even number of parts. Now I am going to divide into even number of parts, equal parts you have to divide. So it is 6 centimeters theta O. That means each part is each division is 1 centimeter length. So mark again the same number, join with the help of a straight line. Vertical line. Okay, mark this. 1, 2, 3, 4, 5, 6. Similarly, divide return stroke into equal number of even number of parts as we have divided this outstroke angle, that is the return stroke. Now mark this into equal same numbers: 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash, 0 dash. Now It is the motion of the follower is uniform velocity. The uniform velocity gives the straight line. That straight line is, suppose is the corner O, and this corner, make it top corner P, and this top corner Q, and end is O dash. So join O and P directly. It is a straight line. And next one, Q and O dash, join it. So this is the curve. The curve 0, P, Q and 0 dash. That curve is the displacement curve. It is the curve. Again, I am drawing here. OP, PQ, OP, that is 0, PQ, 0 dash. This is the displacement diagram when the follower is having uniform velocity during outstroke and return stroke. So these points are there. How it will be useful? Mark it this intersection with 1 dash or A. You can mark it 2 with 2 line, that is P. 3 vertical line intersecting the inclination, that is C. It is D and E, P. Similarly Q, you can make it E. This F, you can consider it as it is E dash. It will be easy. And it is a D dash, C dash, B dash, A dash. So these vertical distances, very important portion. Now here the 120 degree divided into 6 number of parts. This 120 degree is divided into 6 equal parts. That means each part indicates the angle of rotation of the camera of 20 degrees. It is at 0 angle at one position, horizontal x square. If you consider at one position, it is a 20 degree of rotation. The 20 degree of rotation, the distance is the distance or the lifted by the lift follower. The raising of the follower is this much distance 1 to A. If you take the scale and measure, it comes how much it is. Next 2 to 3, 2 to B. 2B is for next 20 degrees of cam rotation. That means for 40 degrees of cam rotation, the lift of the follower is the distance from 2 to B, vertical distance. For next 20 degrees, that means initial total 60 degrees of cam rotation, this is the portion. That is 3C. 1A distance is first 20 degrees. 2B distance is 20 plus extra 20, that is 40 degrees of cam rotation. 3 to C vertical distance is 60 degrees of cam rotation. 4D is 60 plus 20, 80 degrees of cam rotation. 5E is 100 degrees of cam rotation. And finally 6P is 120 degrees of cam rotation. That 120 degrees of cam rotation, the lift of the follower is 50 millimeter. That is the maximum lift is taking place here. This is the distance of maximum, that is 6P. So this is the 6P is the distance from, that is the maximum lift of the follower. Next, what will happen? This is P and Q, neither coming down nor rising of the follower. This is the constant at the constant position. Next, Q and 6 dash. This is the maximum lift. No, it begins again 120 plus 60, 180 degrees. Here the cam is under rotation. 180 degrees. Next 20 degrees, that means 180 plus 180 plus 20, that is 200 degrees. For 200 degrees of cam rotation, now it comes down. The coming down position you have to take it. This is the position. It comes down. Lift comes down. So we know we have taken this distance 6 dash, 5 dash, 4 dash. I am considering here it is on the top actually 5 double dash. Okay, taking 4 double dash, 3 double dash, 2 double dash, 1 double dash. Now this is 0 double dash. Now the lift, the coming down, return stroke means the follower comes down for 200 degrees of rotation, that is 5 double dash E dash. For the next 20 degrees, 200 plus 20, that is 220 degrees of cam rotation, follower comes down. This is 4 double dash D dash, distance comes down. Next 3 double dash C dash is the distance follower coming down for the next 20 degree, that's 220 plus 20, that is 240 degrees of cam rotation, that is 3 double dash C dash. Now 2 double dash B dash, that is the rest of 360 degrees, 2 double dash B dash. Now for 280 degrees, what is the distance coming down by the follower? Return stroke during return stroke. This is the distance, that is 1 double dash A dash. Next 280 plus 60, 280 plus 20, 300. How much it is? No. Here the portions are different, not 20 degrees partitions here. It is divided into how much angles? Not it is 180 plus. 180 plus, what is the angles? 180 plus the divisions 90 degrees by 6. 90 degrees by 6, each is 15 degrees. So the next 15, that is 180 plus 15, you have to add. That means that is a 5 double dash to G dash. So the next distance, that is 4 double dash D dash, is 180 plus 15 plus 15. That is 4 double dash D dash. This 3 double dash C dash is comes by the follower. What is how much here? 180 plus next one more 15. Like that, 15 plus 15, that is 2 double dash B dash. So 1 double dash A dash, that comes under how much? 180 plus 5 times 15, that is 75 degrees. Next O double dash, 0 double dash, 0 dash is the distance of 180 degrees plus 75 plus 15. That is the distance traveled by 0 double dash 0 dash, that is 300 degrees. Okay, 270. It comes under how much? 180 plus 90, that is 270 degrees. That is the distance. Finally it comes down. So what is the distance? The follower comes back for the next 90 degrees, that is at 270 degrees, it comes down to 50 millimeters to comes down 0. There is a height 0 double dash to 0. It comes down from 50 millimeters to 0 millimeters. The next portion, this is the portion for the rest of the 90 degrees, the cam profile, the follower remains constant. It doesn't neither go up nor comes down. This is the displacement diagram for one cycle of the cam rotation, for one rotation of the cam. For one rotation of the cam, this is the displacement diagram. Then what happens for the next revolution? The next revolution comes again, it will be continued. This diagram, same diagram will be continued for the next rest of the same diagram continues for the rest, for the next cycle, for the next rotation of the cam. In that manner, the displacement diagram, the shape of the displacement diagram, when the follower is having uniform velocity motion, how for number of cycles it will taking place is The uniform velocity case we are considering. Uniform velocity case, the shape of the cam profiles for 2-3 revolutions, it comes, okay, how the shape will come. This is the shape of the follower. So it will be continued. This is for one cycle, for one revolution. For the next revolution, this is the portion. Okay. So like that, for number of revolutions, the shape of the displacement curve will be, and so on. Like that it goes on. So is it like is the shape of sawtooth. The shape of the displacement diagram of when the follower is under uniform velocity motion, it is a sawtooth profile. Like you can consider also, it is also shape of a acme thread. Okay, like that it looks. So that the horizontal line indicates the dwell and the starting line. This is the outstroke portion. This is outstroke, and this portion is the return stroke. And it is, this portion is dwell, theta RD. This is theta O, this is theta OD, this is theta R, theta RD. Again, after that begin again theta O, theta OD, theta R, and it is theta RD. In that manner, the motion of the follower takes place. Now, we studied only one case. Second case. When the follower is under simple harmonic motion. Again, time scale, you consider it, the theta O equal to 120 degree. The scale is 20 degrees equal to 1 centimeter. The theta O becomes 6 centimeters here. The scale on x-axis scale is how much? 20 degrees equal to 1 centimeter. Then theta O becomes 6 centimeters. Then theta OD, that is 60 degrees. So 20 degrees equal to 1 centimeter, it becomes 3 centimeters. Theta return, that is how much? 90 degrees. 20 degrees equal to 1 centimeter, then 90 degrees becomes 4.5 centimeters. The rest of the rotation of the cam is the dwell, that is theta RD, that is 360 minus sum of theta O, theta OD and theta R, that is 360 minus of 120 plus 60 plus 90, that is 360 minus 270, that is 90 degrees. That is equal to same as 4.5 centimeters. Now what about y scale, y axis? The y axis equal to 1 centimeter, equal to 1 centimeter. That is the length of the y scale. Y axis indicates y axis. On the y axis will mark what? We consider it the lift of the follower. Lift of the follower. Alright. On the lift of the follower, 1 centimeter equal to 1 centimeter, that is 50 millimeters. That means 5 centimeters equal to 5 centimeters. Draw the x-axis and y-axis. Number of times I am telling, use geometry instruments and draw the straight line and mark it. This theta O, outstroke, dwell, that is 3 centimeters. Next extension, how much? The next extension is theta R and theta RD. Each part is 4.5 centimeters. This is axis X. What about axis Y? That is 50 millimeters. this box is constant for all types of follower motion. So what is this height? Height of the y-axis equal to 50 millimeters. Next, join this. Divide this outstroke and return stroke with the even number of parts, even number of partitions. Now here return stroke is how much? The return stroke is 4.5 centimeters. Divide into 6 equal number of parts. So how to divide this 6 number of parts? That is 45 millimeter by 6. Okay, 7 6s, 8 6 48, 7 6 42, 7 7 49. So how to divide equally 6 equal number of parts? So you consider it 6 into 7s. So which method you have to use? This is 6 7s 42, 6 8s 48. But how to divide this 45? Which method you have to follow? Okay, I am going to explain here how to divide this 45 millimeter into 6 number of parts. So 45 by 6, it comes as, that is, each is 7 points, some percent, some decimals length is required equally. Now how to divide that? We are going to follow or use the concepts of engineering drawing. That's why the prerequisite for this subject is the knowledge of engineering and engineering mechanics. Now here I am going to show you first theta O is easy. Theta O is how much? 6 centimeters. That 6 into 6 equal parts, that each partition is 1 centimeters length. Now you can divide easily. One centimeters equal divisions. Now join this. Equal divisions into vertical. Now this is the 0, 1, 2, 3, 4, 5, 6 parts. Now coming to the point of how to divide this 4.5 centimeters into 6 number of divisions. Now the concept of engineering drawing is that take any inclination of angle that is less than 90 degree. Okay, angle of inclination, that you consider it as a 6 centimeters length, equal divisions. This is the length of 6 centimeters. 6 centimeters. We want 6 divisions. Now take your mini drafter set square exactly. Join this part into equal number of divisions, that is 6 divisions. This is 6, 0, or you can take it as 0, 1, 2, 3, 4, 5, 6. Take your mini drafter and fix the scale by joining the line of this portion and this portion. Then next, with the same scale, move parallel lines you have to draw by passing through this point. It may intersect anywhere. Now, even though the way I have drawn manually, it is not equal parts. But if you fit the mini drafter scale to this O and this corner and fix the mini drafter, join a line and draw the parallel lines passing through the equal divisions of inclined line, then you will get it equal number of parts. Alright. Now, what is the partition number? This is 6 dash, it is 5 dash, 4 dash, 3 dash, 2 dash, 1 dash and 0 dash. Now join these vertical lines. After joining this, in the case of simple harmonic motion, it is like a sinusoidal curve comes. When the motion is moving, it is like a sine curve. It is simple harmonic motion. The concept of, in the case of simple harmonic motion, the acceleration is directly proportional to, that is A equal to minus omega square x concept. That's it, is some curve line comes. Okay. How to do it? The procedure to draw is how to draw that curve. So divide this vertical line, divide the center line, draw a center line, center point. From the center point, take the radius, that is 25 millimeter, draw a semicircle. Divide the semicircle, that 180 degree portion, into 6 number of partitions. That means each partition indicates angular division is 30 degrees. Now it is 1, 2, 3, 4, 5, 6. Now draw horizontal lines from this one point angular division of semicircle, pass through the vertical lines. It is intersecting, one is at 1 vertical line, and draw a horizontal line 2 and 2. Next 3 and 3. 4 line with 4. 5th division point with 5th vertical line, and 6th division point with the 6. Join all these points with a smooth curve. That curve is not that joining line. That curve is not a straight line. It is a curved line. That is A equal to minus omega square x concepts. We can validate here. It is like a sinusoidal of curve comes. Now here, the path trace, this is the portion, this is the curve. How the curve is coming, you see, sinusoidal curve. Similarly, pass these points on the 5th line. This is similarly 4 dash vertical line, and 3 dash, 2 dash, 1 dash, and 0 dash. Now again join with smooth curve. This is the curve. This curve indicates the displacement curve of the follower when it is having a motion of simple harmonic motion. When it is having a motion of simple harmonic motion, this is the curve, displacement curve. Now here, what it indicates, the downward portion, when the crank angle, when the cam rotation is at 0 degrees of rotation from starting point, it is at 0. Next, when it is rotating 20 degrees of cam rotation, next, the motion is 1, 2, A, B, mark it here, C, D, E, F. It is F dash, E dash, D dash, C dash, B dash, A dash, and O dash. Now during the lift, the vertical lines, for the next 20 degree, 20 plus 20, 40 degrees, the distance is 2 to B. 2B the height moves. Next 20 degrees of rotation, C height. Next 4 to D, 5 to E, it moves. Next it goes 6 to F. So the maximum distance traveled by the lift of the follower is how much? 50 millimeters. Then after that it comes down. It comes down, this is the portion. So while going, rising and coming down. So what is the maximum it comes back? 50 millimeters. Maximum it rises 50 millimeters. So the 6F is the distance. 6F is 50 millimeters. And also O dash to this point. You can take it. This is the distance. So this is for one revolution of the cam. Alright. So this is the displacement diagram when the follower is having a simple harmonic motion. Alright. Next, the third case is when the follower is having uniform velocity, uniform acceleration and retardation. Let me complete. When the follower is having, now what is the first step? When the follower is having uniform velocity, uniform acceleration and retardation. Uniform acceleration and retardation. Again, as usual, you follow the x-axis scale and y-axis scale, draw a rectangular box. Now, by joining these vertical lines, join the vertical lines 1, 2, 3, 4, 5, and it is 6. Similarly, the outstroke also divide into equal number of parts. Now, during the motion, it is uniform acceleration retardation. How to do it? Divide the center 3 line into equal number of parts, vertical parts. This is, I am dividing equal number of vertical parts. This is point, you can consider it again 3, 0 here, 1, okay, 2, 3, 4, 5, 6. You follow this notation. Then what will happen? You intersect, join the inclined lines from this corner. Then from the top of this point P to again P5 and P4 and again P3. The intersection 1 with 1 line, this is the point, that is the location of the displacement, that is the tracing point. This is the tracing point. Next 2 with 2, this is next tracing point. 3 with 3 vertical line. 4, next to 4 line. 5 with 5th. This is the 6th point. Now join all these points through a curve. That curve indicates parabola. The parabolic shape of a curve. When the follower, lift of the follower is under, when the follower is having a motion of uniform acceleration and retardation. Same procedure you follow for the return stroke, because we are considering the outstroke and return stroke. During outstroke and return stroke of the follower is having uniform acceleration and retardation. Similarly, this 3' center line divided into equal number of parts. Then again join very carefully here. Now this 1' here, 2' intersecting and 4' intersecting 4' line, and it is 5' line. Join all these points with a smooth curve. The same procedure you follow. This curve indicates the displacement curve of a follower when it is having uniform acceleration and retardation is a double parabola. The parabola for outstroke and parabola for return stroke. Now, the length of the curve may be different because during outstroke, the angle of rotation of the cam is 120 degrees. The return stroke, it is coming very quickly. That is for the next is 90 degrees. So outstroke takes more time because the more angle of rotation, and return stroke comes back very quickly because of less angle of rotation. So the motion of the follower is dependent on the angle of cam rotation. The motion of the follower means during rising and falling, return stroke, outstroke and return stroke, the time of outstroke and return stroke is dependent on the quantity of the angle of rotation of the cam. So with this, we have studied 3 cases how to draw the displacement diagram. The main thing is that during outstroke and return stroke, it is the same motions. If we consider outstroke is uniform velocity, the return stroke also uniform velocity. And here we consider for type of the same cases we followed, that is uniform velocity motion. When the follower is having uniform velocity motion, what is the displacement diagram? When the follower is having simple harmonic motion, what is the displacement diagram? When the follower is having uniform acceleration retardation, what is the type of displacement diagram? Now, this is the key thing is that the outstroke and return stroke, the follower is having same motions. If in the case of outstroke is one type of motion and it is return stroke of the follower is another type of motion, then how to draw the displacement diagrams, those cases will be studied in the next session of my class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.